Hey, thanks for checking out this stream. I'm just going to post a message in the chat here. Hopefully that goes through in just a sec. Just to say that basically I will be trying to watch the chat as I'm presenting, so if you have questions, comments, please feel free to engage there. I will try my best to answer during the stream. I have to kind of watch a second screen to see stuff coming in. It's slightly delayed, so just heads up on that. And then, of course, if you're watching the recording of this, you won't have the chat available to ask questions, but please use the comments. I will respond. So, the topic for today that I want to go over is about object oriented programming. And this is going to be a beginner focus. So, I'm actually going to spend the beginning of this. I don't want to push it to an hour. I'm hoping in about 40 minutes we can kind of wrap this up. But I'm going to spend the beginning portion of this kind of just talking about object oriented programming in general, introduce the concepts of inheritance and composition, kind of compare and contrast them. I will share right now that I do have a bias to not use inheritance, but it is one of the things that we're taught pretty early on in programming. So just a heads up, that is my bias. I will try to offer some insights as to why that is the case. And because this is beginner focused, I'm not going to be diving into more complex examples in code that might illustrate that. So we'll see how far we get. And then the other thing I'll mention is that when we do get into some of the code, depending on how much experience you have at all with programming, for some folks that might be literally zero, that's okay. There might be some terminology that might not make sense. I will try to go very slow, explain what I think are very beginner concepts, but if I'm glossing over them, again, please ask in the chat. I will try to pause and just offer a little bit more explanation. Okay, that's my my preamble. So, object-oriented programming. For me, this is something that when people ask me about programming and why I enjoy it or if it's hard or anything else like that, I always go back to telling people that I look at programming as if it's like building Lego, except I have unlimited Lego bricks and I can create any Lego brick that I can think about. So the reason that that metaphor really clicks for me is because of object-oriented programming. So to try and give you a bit of an example here, I think some of us when we're learning how to program, of course, some of the first programs that we write are, like a simple script or something that just does a couple of operations. Maybe it's, we see the hello world example. You're printing something to the console, or maybe you're playing around with adding some numbers together. It's really simple things. Now, when you extend that a little bit and try to think about reusing that code, you want to kind of package it up into something. We don't really know what this something is yet because we're still kind of getting, introduced to programming. We want to package it up to reuse it in other parts of our program or in bigger programs. So what does that look like? And I think object-oriented programming really like facilitates that ability for us. So I want to give you a concrete example. I'm just trying to make up something off the top of my head. If you wrote I don't know, this is tricky. If you wrote a program that was like, one of your first programs, maybe you want to rename some files in a folder to follow a particular format, for example. You might write that program, and at the very beginning of the program, it starts going through file by file, renaming things. Kind of feels just like a one time run, and it's like a script, right? You'd go run it, does its job, great, you kind of forget about it. But if you said, hey, I want to be able to reuse this functionality, what you might do is actually take that program and the code for it, and you would put it in what we call in a lot of programming languages a class. You could put it into a class inside of a method for that class and then be able to call that and reuse it. So the word class is like an object that we would be able to reuse in our code. So this is kind of like a really basic intro to it, but there's a couple of different flavors or two primary flavors I think that we see for this, and that would be inheritance and composition. So I'm going to start by explaining briefly what inheritance is and then briefly what composition is. Spend a little bit more time on inheritance and then kind of the same thing for composition. So when we think about inheritance, as the name implies, it's designed to be able to inherit, right, functionality from an ancestor. So a lot of the time in programming, we are looking to essentially minimize the amount of copying and pasting of code we're doing. So if you have functionality that works in a particular case and you want to have that same functionality somewhere else, instead of just copying and pasting, maybe 10 to 100 lines of code or something, duplicating the whole thing, you might have it in an object and you might be trying to do that to reuse it. Now, when we have inheritance, what we're able to do is put some functionality, characteristics, or properties into an object, and we would call that, let's say, it will be our ancestor or our root. And then what we could do is actually inherit, so have another class that inherits the functionality of that base class or the ancestor, and then actually access that functionality. And not only access it, but depending on what we're doing in inheritance, we could modify it, we could override it, we could tweak it in some way and kind of make it our own. So you can keep extending this functionality such that the more levels that you have in your hierarchy, the more like layers of customization that you can make to your original object. I'm going to briefly jump to composition and then I'll come back. So composition is almost the opposite of this in terms of how you organize things. So instead of having a hierarchy where you would say, I want one root object, and then I will inherit to sort of extend the functionality and reuse it. Instead, you make many small objects. Each of these small objects is mostly purpose built, right? It will have particular functionality, kind of very specific to this object itself. And then you use those as building blocks for larger objects. Now, again, the difference is that you are making objects, like more complex objects, out of smaller ones, right? And then you can keep extending that pattern such that your complex object with another complex object could be used together in yet another more complex object. So it's kind of like I would think about it like wrapping things around objects, and inheritance is sort of this hierarchy. Okay, so let's maybe think about a couple examples here, and then I might try to jump over to code. We're almost 10 minutes in, so it might be a good time just to actually start looking at something. So when we talk about inheritance, maybe an example, two that come to mind that work pretty well, I think, for non-programmers to kind of relate to this concept, or if you're a beginner programmer, it might make more sense. Animals. So animals inside of programs, maybe that's a little bit of a weird concept, but just to demonstrate what inheritance means. If you had a class that you wanted to sort of define functionality and characteristics for an animal, you could create a class that was called animal, and then you might introduce a couple of properties or functions that you expect that animal to have. So, for example, you know, all animals might have a function that says eat because every animal will eat, and all that same class might have a function that says reproduce, right? Because all animals should be able to reproduce, and maybe it has characteristics like the color, right? I'm really really simplifying this because an animal is actually a pretty complex thing, but you might have color, you might have weight, just some properties that define that. And the idea is that these functions and properties that you're putting onto your animal ancestor class, these are actually things that more specific types of animals would inherit. Okay, so if we have that, where do we go from here? Well, you might be able to say then, okay, well, I want a mammal or I want a reptile. So you could introduce a class for a mammal and a reptile that inherits from animal, right? Because both mammals and reptiles are animals. And then from there, you could actually access some of the functionality, right? Like eat, reproduce, but you might want to actually be able to override some of the other characteristics. Now, I'm not going to get into the biology of mammals and reptiles. I actually recorded a video on this already and messed up mammals somehow, which is pretty embarrassing. But the idea is that maybe like reptiles, you could talk about the type of the type of skin that they have. So you could override some characteristic that was from animal and talk about the skin there. And for mammals, maybe there's some functionality or characteristics we could override for something to do with like body hair and things like that. So from there, because that's just one extra layer in the hierarchy, you could go yet another layer. And spoiler alert, you can keep doing this with inheritance, but for mammals, maybe you want to do like a dog class or a cat class. And then from there, another level could be the breed of the dog or the cat. And you can keep doing this, and you end up getting to reuse the functionality from the more ancestor classes, and you can override or tweak and tune those characteristics or functionality in the child classes. So I think a lot of the time, like people are taught this very early on in object-oriented programming. And personally, I think that it sticks with people because we have so many of these examples that are like real world, like you can relate to it. I think the animal one's pretty good. I think vehicles are another interesting one because you could even talk about like um, like transportation type, and then you could have like car or truck or boat or plane, and then like bicycle. You can have all these things that kind of inherit, and then like a hierarchy that you build out of it. But let's jump over to composition because I think composition is the thing that I do want to spend arguably a little bit more time just explaining because I think that there's more benefit in understanding it because long term, I think that's what people should be focusing on. Again, I tried to call out this bias a little bit earlier. So I mentioned composition is about putting objects inside of something else to make a more complex one. And I like using vehicles for this example because I think that something like a vehicle is actually a really good way to think about something physical from the real world where this concept really makes sense. So if I said we want to have a vehicle class, in the inheritance example, you might say, okay, we have a vehicle and then we want to inherit from that to have a car or inherit from vehicle to have a truck. And then from there, you could have like the specific models of cars and trucks and that kind of thing. And if you continue that thought process, you might say, well, then we want to override the functionality for like how fast it goes, like how fast it accelerates, the fuel consumption. So it seems like it's pretty easy to apply the inheritance part, but composition, I think, really works here because if I said I want to create a vehicle, well, what goes into a vehicle? Well, there's a lot of things that go into a vehicle, and I am certainly not an expert. I love cars, but I'm not going to try to pretend like I can name every component that goes into a car. But just to think about a more simplified version of this, if you were to create a car, some of the pieces that go into a car, you might say, well, it needs seats. Okay, so that's one of the type, like one of the objects that would go into a car. And you can say how many seats. And then a car also needs an engine. Okay, and maybe a car will have a spot for a spoiler. I don't know. Think about if you play racing games, think about some of the things that you can modify. Like a car will need brakes, right? A car will need wheels. So you could go create your vehicle class, and instead of inheriting from vehicle, you would start passing in other objects that make up your vehicle. But this chain that I was talking about from inheritance, you can have a similar sort of approach for your composition pattern. So what do I mean by that? Well, I mentioned engine, for example. Now, if you're thinking about the engine of the motor in your vehicle, that's also an extremely complicated thing, right? It's not just like a simple, like we wouldn't have a simple class that defines that in code. So you take that same approach and you say, okay, if I want to now make an engine, what goes into that? Okay, well, you might have rods, pistons, you might have properties that define the type of material, right? So you start passing in all this information as smaller objects into your engine. So if you can kind of conceptualize this, to use composition, we need to first create all the small little pieces, and then start packaging them up and then put those into more complex things. So now I'm about 15 minutes in, and I think we'll jump over to code now so I can start showing you what inheritance would look like. We're going to use C#, and then I'll show you what composition looks like as well. And I will try to wrap up by giving you a little bit more context, still try to be beginner focused on why I truly think that you want to spend a little bit more time trying to understand composition over inheritance. So give me one sec here. I will switch over to .NetFiddle. If you want to play, like follow along in your browser and play along, you can check out the URL that I have in the screen that I will be sharing in just a sec. It should be showing right now with my face on the top right corner. And yeah, so you can see .NetFiddle.net up at the top here. The code that I'm going to be writing isn't going to be anything spectacular, so you can probably just, if you want, just watch, or you can follow along and try things out. So C# is the language we're using, and C# itself is an object-oriented language. And one of the things that is already interesting, the code that's on the screen here, I'll zoom in one more time. The code that's on the screen here is basically the very first like I didn't write this, it just kind of shows up on the screen. It's actually like the Hello World program, right? So it's one of the first programs that people write. And in C#, you can already see that it says public class program. You heard me say class earlier, and it's because in C#, a class defines an object. So going back to C# being a object-oriented language, even our program, like where our entry point for our program is defined inside of an object, and that object is called program. So just a little little tip there, just so you know. Okay, so I want to start with inheritance. And to do inheritance, I think I want to actually I want to try using a similar example for both inheritance and composition. So let's stick with vehicles because I think that vehicles will probably be a little bit easier when we get into composition. But let's go ahead and start. So in inheritance, we want to define our sort of like our ancestor or our base class. So I'm going to start with vehicle. And you can see that all that I'm doing here is I've kind of like how we had for program. I just have a class that is named vehicle. The public part, you don't really have to be concerned with that. That's just how visible this is for other people to be able to see. So not to really worry. But this part here is how we define vehicle. And inside of the curly braces, we don't have anything right now. So that means that our vehicle doesn't have any properties, so no characteristics, and it doesn't have any functionality defined by any methods. So right now our vehicle doesn't do anything at all, pretty boring. But just to show you how inheritance looks, I'm going to copy and paste the vehicle, and I want to have a car. But a car is a type of vehicle. It inherits from vehicle. So by using this syntax here, the colon and then vehicle after the word car, this tells us in C# that a car is a type of vehicle. And I'm going to do the same thing now for truck. Again, as I'm doing this, just so you, like to point it out again, there's no functionality yet. I'm literally just assigning some objects that have a hierarchy to them. So hopefully this makes sense, this syntax. Again, if you're not familiar with it, that's okay. But we have now 3 classes on our screen. The vehicle is the topmost ancestor in this hierarchy. Then cars inherit from vehicle and trucks inherit from vehicle as well. Now, you could do another level of, let's say, of car. So I want to have a type of car. Well, I want a Lambo. Everyone wants a Lambo. So a Lambo inherits from car, which also inherits from vehicle. right? So to kind of think about this, you'll like again, Lambo inherits from car. It does not inherit from truck. So a Lambo is not a truck. A Lambo is a car and it is a vehicle. So hopefully that makes sense. I don't really know many trucks, but you could basically do the same type of thing and inherit from truck with your own type of specific model of truck. Okay, so we kind of just chatted through how the hierarchy works and how we actually inherit, but what do we want to do with that? Well, let's go ahead and maybe introduce some functionality and some properties. So we could have something like, we could have, I don't want to, this might make it a little bit more complicated, so I apologize, but when we talk about the data types that we're going to use, I'm either just going to use Booleans, so true and false, strings, so words, or integers or floating point numbers, just so we have some numbers. Just as a heads up, because what I was going to do is say color. There is a data type for color. I'm not going to go using it because it's going to get kind of messy. So we'll just have color. So you could have a vehicle. So every vehicle, because it's a physical thing, might have some color associated with it. Okay, now what's interesting about this is that if we think about color, color doesn't actually change based on the type of vehicle that we have, right? So that might not make a lot of sense in this example, but it's a property that exists on a vehicle. What about the weight, right? So we could say public float for a number, weight in kg. Now, okay, this is probably the same issue, right? The weight is not actually going to be assigned by whether or not it's a car or a truck or a Lambo, right? These are just characteristics that exist on a vehicle. Okay, so how do we make this feel a little bit better? How do we start looking at like what differentiates a car from a truck? Well, we could say that maybe by definition, all trucks have beds on them. Okay, so what we could do is we could do public float bed width. Sorry, the microphone's right in my face and I can't see my keyboard as I type. Bed width and bed length. So what's interesting here is if we were to look at what properties a truck has, a truck now has properties that define the bed of the truck, right? But because it inherits from vehicle, a truck also has these two other properties. And that's because we said every vehicle will have color, it will have some weight in kilograms, it will have a width and a length for the bed for a truck. But car, and then by definition Lambo, will not get these two properties. And that's because the way that we've defined what a truck actually is, these two properties will never exist on a car. And unless you wanted to make another subclass of some maybe Frankenstein Lamborghini, you're also not going to have a bed on your Lambo. So there's one super quick example. Okay, now you can keep doing this type of pattern where we could go look at, well, what makes a car unique? And then you could say, well, what makes a Lambo unique? But let's talk about functionality. Okay, so let's, this is going to be really contrived, so I apologize. I just want to kind of show you what you're able to accomplish here. So we might have, like every vehicle should be able to drive, hopefully, right, if it's running. So you could have methods on here like start the vehicle, stop the vehicle, accelerate, decelerate, that kind of thing. Steer, so like, turn left, turn right. I'm just going to really simplify this to say drive, just to keep this example short. So public void drive. Okay, so what's interesting, and I'm saying this is contrived because I just want to be able to demonstrate some other language features here. And heads up, these language features that I'm going to talk about are in C sharp, but the concepts are certainly applicable to other programming languages. It's just the terminology might be slightly different. Okay, so every vehicle should be able to drive, but because I put this method drive right in the ancestor class vehicle, it now requires me to be able to say how it drives. Well, in the ancestor class vehicle, I actually have no concept of what we even have to work with here. So instead of actually defining this function like this, what I could do is say, look, in the base class, like in the most ancestor class, I don't know how to drive. I know that a vehicle should drive and it must have that functionality, but I don't have enough information to say that. Other people have to define that for me. So then we can use this keyword called abstract here. And then what that means is that we have to make the class itself abstract. Okay, so this might already sound super confusing, but what this will mean by using the keyword abstract is that in our code, we can never write the following syntax. We can't say vehicle, my vehicle equals new vehicle. We can't do this because vehicle is abstract. If I took this part off, it would allow it. So we can't make new instances of vehicles, but we can make new instances of the non-abstract classes. So if I wanted to make a new Lambo, that would work because a Lamborghini in our example is not marked as abstract. So just again, to repeat a little bit, abstract is a keyword that suggests to the compiler that this class is sort of not complete. It is a base class, it's a piece of what we need, but we need to have another class that inherits from it to be able to actually use it. Okay, so now that I've done that, you can see car, truck, and Lambo's fine, but car and truck aren't in good shape. We have an error, and it says that car does not implement the inherited abstract member drive. Okay, so we can actually do the same thing and mark this one as abstract and this as well. So what's actually happening here? So what I'm now saying by having car and truck also marked as abstract is that the three things, vehicle, car, and truck, we can never put any of those things here. We can't just make instances of vehicle, car, and truck. We have to make specific implementations for each of the models of these that we want to use. And that's why Lambo, if I could type it, Lambo will still work for us here. But there's a problem. Because now Lambo also does not implement this abstract member drive. So what we could do is we have to say public, we have to go implement drive. And again, because I said this is going to be super contrived, we'll just write to the console so it'll show up down here where it says hello world. I'll just say Lambo goes fast. And now in my program, I could say my vehicle dot drive. Oops. And if I run this, hello world, and then Lambo goes fast. So not super exciting, but just wanted to show you that that's what abstract does. And then when we actually go to implement it, we can override that functionality. And in fact, Lambo has to override that functionality because it's not abstract anymore. and we will put this implementation in. We can make a slight adjustment to this just to show you something else that's not abstract. It's another flavor of it, and it's called virtual. So what I will do is instead I will leave this one as abstract, so that won't change, but I'm going to make car and truck actually not abstract now. Now that means to make the compiler happy, it needs to implement the drive method. And we can go do that. I'm just going to copy and paste this just because I'm super lazy and I don't want to mess up my typing. So we can go do that. But this of course is now incorrect. I need to say car goes at normal speed, right? I don't know. And then maybe trucks are slow. Sorry if you have a fast truck. I know not all trucks are slow, but so if I go back up to the top here, I still can't put vehicle here, right? Because vehicle is abstract. We cannot make a new instance of it. I can put car here. And if I go run this, car goes at normal speed. I can put truck here. Truck goes slower. And if I put Lambo, Lambo goes fast. So this behavior I talked about at the beginning, right, when I was talking about this inheritance hierarchy and was saying that we get to inherit the characteristics, and then we're able to either inherit the methods that we have, or using some keywords, we can actually override and change that functionality to make it our own. So hopefully that makes a little bit more sense. There's another word, just in case you're curious, that's not abstract. It's called virtual. So I will, before I jump over to composition, I'm just going to change this class from being abstract now, and this is going to be virtual. So because this is not abstract anymore, yes, we will be able to make an instance of this. And we could say that the default, I would never really recommend you programming like this, by the way. I'm just trying to illustrate an example. We could say that when you try to drive a vehicle class and we don't have any other information, what we could say, like, what vehicle do we even have, right? Because like I said at the beginning that we don't even know how to drive the vehicle if we don't even know what it is. So this is just to show you that virtual allowed us to still override here. It allowed us to override here, and it allowed us to override here. So quick recap, we were able to inherit from vehicle. We got to see what using the abstract keyword did. We got to see what virtual does. We could see some examples of basically introducing new characteristics to child classes and then overriding some of this functionality based on what we have here. Then we saw that when we actually called this stuff up at the top, if you're paying attention, you'll notice that this part never changed. What I have highlighted. So anytime I had vehicle, if I had Lambo here, I can actually assign a Lamborghini to a variable of type vehicle because a Lamborghini is a vehicle. It is a car as well. Oops. Right? So this should also work. Right? No errors. Okay. Now I'm about 35 minutes in. I want to try jumping over to composition. I was hoping this wasn't going to go a full hour, so I do apologize. Let me go ahead and get rid of all of this code. We will start fresh with composition. So I'm sticking with vehicles, so let's go ahead and put vehicle back. Just to prove a point, I'm going to use the sealed keyword here. Sealed means that we are not allowed to inherit from it. This prevents inheritance. We don't need it. I'm just using it so that you know I'm not cheating in my examples. And we will not inherit from vehicle and still try to get some examples going here where we can build up a vehicle. Okay, so early on I said that when we use composition, it's kind of like taking smaller pieces and taking more simple objects, putting them together into a more complex object, and then repeating that process. So I was really bad at kind of listing out the things that go into a vehicle, but let's have another stab at what that looks like. So I said that we could have things like seats. Oops. So we could have seat. I might want to have, I'm just trying to think about, I mentioned earlier, like thinking about racing games and the things that you can tweak on your vehicles. So the different brakes we have. Um, you might want a wing or a spoiler. You could have engine. So these are just a handful of things, but we want to basically pass them into our vehicle because our vehicle needs to be made up of these smaller pieces. So I'm going to make one more small adjustment just to show you another language feature that we have in C#. It's relatively new. It's called a record. In our case here, a record is just going to be like a class, but it's going to let us make this look a little bit less gross. So I want to pass in, like I said, the pieces that go into making a vehicle. So I need an engine. So it will be, this is the type, and then this is the name of the property. And then I need to have brakes. So let's say that for some of these things that our vehicles can have multiple seats, they can have multiple brakes, they can have one wing, one engine. You're free to do whatever the heck you want. I just want to be able to show you multiples. So we could do like an array of seat to get seats. We could do an array of brakes. And then we would do like a wing. Okay. So when I do this, just to go back up to the top here and show you how we would go make a new instance of this vehicle, we would say vehicle It's surprisingly hard to type when I can't see my hands. So new, but we can't just do this. We need to pass in all of the things that go into vehicle. And fortunately, we have that list right here. So we have a new engine. We need a new array of seats. So let's say that in our vehicle, it's only a two-seater. So I'm going to, one seat, there's two seats. Boom. Two seats inside of an array. What's next? We need brakes. Well, we're going to have two brakes in the front and two in the rear. So another array. For those that aren't familiar, this syntax here with the square braces, this is just how you denote that you're creating an array. So new, right? So I'll do that and put 4 of them in because we need 4 brakes for our vehicle. And then the final thing is the wing because every cool car has a wing, right? Okay. And it doesn't all fit on the on the screen. I can't adjust the size of this. I can zoom out a little bit. There we go. Hopefully that's still legible for you folks. But you can see that vehicle, it's a lot more verbose when we're declaring it and making a new instance of it. But we don't have any inheritance hierarchy to be able to do this. So something that's kind of cool. It's just a slight tangent for what the record type is. I mentioned it's very much like a class. It just gives us some other built-in functionality that's kind of nice for what I'm about to show you here. So I can actually print out what that record looks like. And it's a little bit more readable. than a class would be by default. So if I go run this, you can see that it says, okay, we have an engine. Now this part looks a little confusing. It says program plus engine. That's my bad. Let me go ahead and I'll rerun this in just a sec. I'm going to move all these things outside of our program class. Recall at the beginning, I said that we are all inside of this program class. So I'll just pull those out. Oh my goodness, the tabbing. There we go. I'll run it again. Okay. Now it's a little bit more readable. You can see that we have the engine is set to be an engine. The seats, it doesn't show you how many. That's just a limitation of this, of the record kind of printing out to the console. But we have an array of seats, we have an array of brakes, and we have a wing. Okay, cool. So this part seems probably super boring because you're like, well, that's nice. We can just keep listing off the things that need to go into a car or into a vehicle, right? But now I want to show you, instead of overriding things, how we can change the functionality. And this part to me is super cool because you can basically, remember my analogy at the beginning was like Lego bricks. You can go make anything that you can think up. So if you're familiar with playing with Lego, if you've ever tried to build something out of a set and then you took it all apart and you said, I want to make my own stuff, and you start building something up and you're like, oh man, I wish I just had some piece. Well, now you can. So we have this engine. It's kind of boring. It doesn't actually do anything, right? So, I mean, none of these actually do anything. But what you could do is we could maybe, just to make this a little bit more interesting, I'm going to show you another couple of things. I'm trying to be cognizant of time here. I'm going to introduce our first interface. And you might say, well, that sounds scary. What is an interface? An interface is sort of like abstract classes that we saw earlier, except it's not a class. It just defines this sort of like literally the interface. So the characteristics or the methods that you should be able to see on an implementation, but it is not an implementation. It does not provide any functionality by default, whereas an abstract class is able to do so. So we could say that an engine, I'm going to, again, use some really simple properties here, might have something like float displacement in liters. And then I want to do like, we'll do an integer for number of cylinders. Okay. And then I will actually make this, we're going to make two different types of engines here. So the engine that I have in my car is an Audi TT. So the engine that I have, just to make this a little bit more explicit here, I need to have this part to say that my class Audi TT engine must inherit from iEngine. And you'll notice that it says it doesn't implement these two properties. That's okay. We'll just go put those on. And it needs to have public. That's a requirement for an interface. And then we have to actually provide some values here. So I have a 2.5 liter, and it is a 5-cylinder. Kind of weird. Just looking here, oops, my goodness. It wasn't a string, there we go. And I'm missing a semicolon. Okay, and then we could say my fiance drives our AMG GT. And I don't know what the displacement is in that. I should probably know. 9,000. It's not, obviously, but it's an 8-cylinder. So, oops, what I want to show you is that we can actually go change. We can go change the vehicle entirely and just swap out the engine by having two different implementations here. So we'll start by putting the Audi TT engine in. Sorry, I forgot. I need to change the syntax here because this needs to say iEngine now. If you recall, I just introduced that interface, so I need to pass that interface in. So an Audi TT engine does implement that interface, which means we can use it here. If I press run, you can see that the engine is an Audi TT engine. And then if I wanted to, afterwards, I could go write out specifically what the engine is. And it says Audi TT engine. Oh, I forgot. I'm using classes. My apologies. Let's go back to record. Will that do it? There we go. Okay. So I don't even need to have that second print line. Again, I'm using records just because when they print to the console, they're formatted a little bit more nicely. So you can see in this example then, why by passing in an Audi TT engine into the vehicle that we get, oh my goodness, I can't spell, displacement. It's supposed to say displacement of 2.5 liters, right? And the number of cylinders is 5. But if we wanted to go, and this is where it gets a little bit unrealistic for vehicles, but if I wanted to go swap this to be the AMG engine, what did I call it? Let me go fix this too. That's going to really bother me. So I'm going to go take that. I think that's incorrect now. Okay, one sec. There we go. What? Oh, I missed this. See, this is why sometimes using these online editors is not helpful. You miss too many things. But what I was able to do is just swap this out, right? Now I have an AMG GT engine in my vehicle. It is way bigger, way more cylinders. Awesome. So we can completely change functionality of a vehicle by swapping the pieces inside of the vehicle. We don't have to inherit and then override things to change them. So hopefully these examples made sense, but you might still be sitting there going, well, Nick, you said at the beginning that you don't favor inheritance. You said that composition is sort of this better way to go, and why? Because it still might not be obvious why, right? We were able to actually accomplish very similar things with both of them. So why would it be better to use composition over inheritance? Okay, so in programming, this is where it might get a little bit more, I guess, complex. So instead of me diving into the actual code to show you, I'm just going to talk about, you need to kind of conceptualize this. So I might kind of jump back to just my face so I can talk with my hands a little bit better. Okay, so when we're talking about composition, I mentioned and kind of illustrated that we're actually taking small things, taking a handful of small things, passing them into a more complex object, and we can kind of keep repeating this. In programming, when we want to be able to test things more effectively, and basically have more flexible code, more extensible code, it's a lot more beneficial to have smaller, more purpose-built objects or classes because they're able to isolate more functionality, and then we can focus on that. So just to give you an inverse example, if I had a program that was one method and 1,000 lines of code, if I wanted to exercise any part of that program, I have to go touch one method that's 1,000 lines of code. That means I would have to go basically run through the same same set of instructions to try and get to a point just to exercise it. If I wanted to change part of that program, again, I'm going into the same 1,000 lines and potentially messing something up. Now, if that program was instead split into smaller pieces, what I could do is I could go write test coverage on pieces of this code, right? When I go do that and write tests on the pieces, when I have to go change something, I might be going to touch one of the pieces. And in theory, that should tell you that if I've touched this piece over here somewhere, and I didn't touch this piece over here, you shouldn't have to go test this other thing. You should feel confident. I touch nothing to do with this. I touch this thing. Let's go run tests for this thing. Now, you can kind of keep extending that concept because when you have all of these smaller, more isolated pieces, not only are they easier to test, but because they're isolated, they kind of give you this boundary where you don't have to go test your entire system. You don't have to lose confidence in your entire system kind of falling apart. Now, with inheritance, why this does not really work, because you might say, well, Nick, isn't all that stuff in the base class, right? That's a smaller thing. It's in the base class. We should be able to test that. Now, yes, but I showed you, and this might not be obvious, which is why I was saying slightly more advanced. When you're going to test some of this stuff, I showed you earlier that when you have that abstract class at the base, you can't make a new instance of it. So to go test that, there's not a lot of tools that make that easy to test. And generally what you have to do is go test some implementation that inherits from that abstract class. So that would mean that in our example from earlier, we couldn't test the functionality directly in the vehicle. And at some point, because I made car and truck abstract, we couldn't test the functionality directly in those. I would have to go make a Lamborghini, because that was the class that I had that was not abstract, just to be able to test the functionality in those base classes. So in my example, it was very contrived because these are really simple objects. But when you start using abstract, virtual, and overriding different methods, different characteristics, and your inheritance hierarchy gets really deep, it's actually very difficult to isolate some of the things that you would like to test in your more like ancestor type objects. And in fact, it can make it really difficult to test things in your child objects because if your ancestor stuff has to execute a lot of code before it will even call something that your child class can override, you don't have a choice but to set up your test such that the whole body of code in the ancestor can get executed before getting to your small piece. So long story short there, inheritance generally does not lend itself well to isolating code to being tested. Another quick note is that, and sorry, I don't mean to like totally bash inheritance, it's just that when you see these things kind of get out of control after many years, there's a lot of examples where it just it's people didn't pick composition probably because they weren't familiar with it. So another example though is that I'm trying to think of a good way to put this. Okay, so when you have really big inheritance hierarchies, in my example, I just showed a vehicle, then a car and truck, and then we had a Lamborghini below car. So only a couple of classes. If instead of just having that, I've seen literally inheritance hierarchies that will have hundreds of implementations. If you go make a change in one of the, and like when I say hundreds of implementations, I mean that could be hundreds, but also spanning, from 2 to 7 or 10 layers deep in a hierarchy. So imagine how complex that might get. And I'm not exaggerating when I say hundreds either. If you were to go change some of the functionality in the root, in one of those more ancestor objects, if you go change that, you now have a cascading effect. It's the exact opposite from composition where it was isolated. You would have a cascading effect that could basically potentially affect all of your child classes. It's not necessarily isolated. So when it comes to testing, how would you prove that you didn't just go break all of these things? Sometimes you can, but a lot of the time that's not the case if it's shared code. That's one part. The other part is that if you were to change sort of like the signature of one of these abstract classes or like an ancestor class, right? If you introduced a new abstract method or property, all of a sudden, everything in my example that I was just mentioning, like hundreds of classes would instantly break, not compile. You would have to go add a property or a method to all of these just to meet your new signature. So I don't want to tell you that you cannot use inheritance, but I would strongly encourage you to limit the scope of how you're using it. I don't think that you should design entire applications where you have large inheritance hierarchies. And I would strongly encourage you to think about writing smaller, smaller, more purpose-built classes, right? Think about how you kind of group a few of those together, wrap them in a more complex object, and keep repeating that process. I would probably bet money if you take that approach, you will find that more long term in your software engineering journey, you will find that code easier to test. You'll find that it will be more flexible, and I think you'll have a more enjoyable experience. So just wanted to share that because I have been guilty of graduating from university in computer engineering, going into my first full-time job, and changing everything to be an absurdly big inheritance hierarchy, and a couple years into it being like, oh my goodness, what have I done? And it's because I did not know better, and I'm just trying to share that with you. So we'll wrap all this up. It did actually end up taking the full hour. I apologize, but we did look at inheritance. We did look at composition. Inheritance allows you to, as the name suggests, inherit from more ancestor classes to gain functionality, right? To be able to reuse it. You can override it depending on how your structure is set up. And composition is just the inverse of that, where we don't inherit from things, but we make objects based on more simple objects passed into it. And just to summarize, I do think that composition will lend itself better to your software engineering journey. So if you're not familiar with it still, please do read more about it. Try to focus on that. And I think that'll work out for you in the long run. Awesome. So thanks so much for tuning in. If you thought this was helpful, please go ahead and subscribe. I try to do these. I want to get to about 2 a month. I'm doing one right now. I want to do one beginner one and then one more advanced one. And we'll see how that goes. So again, thank you.